Teacher Taylor here from the safety of our own homes. So, as you know, class was canceled for Thursday, February 3rd. Instead of doing our regular class time, I thought, well, I'll just make some videos and y'all can watch them and follow along on your own time. So, without further ado, let's jump into coding part 2. We're gonna do like an Arduino IDE lab. So you downloaded it, kind of got like your toes wet with it with the last lecture that Jesse did. And now we're going to become a little more comfortable with using it and with coding in it. So our plan for today, whenever you decide to open these videos, is to go over what a serial monitor is and how to use it in the Arduino IDE. It's going to be a super important tool when you're debugging in your projects. The second thing that we're going to go over is what is the difference between a timer and a delay, and when do you use those things? Hint, we probably want to use timers, not delays. The third thing we're going to go over is pseudocode. Pseudocode. It's super important. I'm not just saying that. I mean it. Pseudocode should take up 80% of your programming time. I just pulled that number out of my ass, but I'm genuinely very serious. I'm gonna stop this for a second because it sounds like my cat's peeing, and it's because he is through our problem in words instead of code, and then how to translate that thought process into code in the Arduino IDE. Lastly, for this class, we're going to kind of go over a few lines of code that you should know in order to complete some coding challenges. Pretty fun, pretty cool, pretty powerful. So yeah, I would recommend having, a window open, that's this lecture, and another window open, that's the Arduino IDE, so you can follow along with what I'm saying and the slides and view it in the IDE as we go along. The serial monitor. So the serial monitor in the Arduino IDE is this essential tool when creating projects like the ones that you'll do in this class that will be used to debug your code. It means my code isn't working right. Why? How do we figure that out? Is it an error with hardware, software? But when we look into how the error could be coming from our software that we wrote or our code, we debug it. Let's open up a fresh new sketch in our Arduino IDE. If you remember from Jesse's lecture, a sketch is just what we call this file, right? It's where we put our code. So we have this setup function and we have a loop function. What we can do is go all the way up here to the top right corner and you see a button. It looks like a magnifying glass kind of, and that's your serial monitor. And you can click that and it opens up. Right now, I don't have an Arduino connected to my computer. So the serial monitor tells me it's not connected, you gotta select a board and a port and it'll connect automatically. What is this, 9600 baud?
Baud rate.
Baud rate, I got it right. Baud rate sets the speed for serial communication. To set up the serial monitor, you'll wanna include this line of code in that setup function. It's going to be serial.begin, and then whatever baud rate is necessary. For this class, we'll probably mostly be using 9600. This is the default baud rate. And what this does is sets the data rate in bits per second, baud, so we can communicate with the serial monitor. So it's kind of like saying hey, serial monitor, is it chill if we talk to each other? And serial monitor is like, yeah, totally. Oh my god, Siri just opened up. I'm not talking to you, Siri. I'm talking to Serial Monitor. So let's go ahead and jump in the Arduino IDE and do this together. So in setup, you can type serial.begin speaking to the serial monitor. So we're gonna type in 9600 and we're gonna end that line of code with a semicolon. We are done with that command. Next, delays and timers. What is a delay versus what is a timer? And what are the limitations of delay and how to do timers correctly. When there is a delay in your program, when you use the delay function, we send in the number of milliseconds. The issue with that is that the program just gets lazy. It's like delay for 5 seconds. For that 5 seconds, the program is like, I'm gonna stop listening. I don't care what you have to say. I'm just gonna chill out, do my thing. And no other lines of code can be executed. That can be an issue because sometimes what you want to happen, maybe we want to keep track of time without making the program completely stop. That's why we use timers instead. We can use this function called millis. It's like milliseconds. And millis with a parentheses with nothing sent in it will return the amount of time that has passed since our program started running. And you can look at what is returned from that function and store it in a variable to determine some amount of elapsed time. When we use a timer, we would have to think about, all right, when does this timer start? Does it start right when the program starts? Or does it start when some sort of user input or event happens? Let's say you wanted to start a timer after a certain event happens. Well, in our loop function, like that second big chunk of what's in our Arduino sketch, you can be kind of listening for an event with a conditional statement. Be like, if this button is pressed, then we want to start the timer. How do we do that? Well, we can make a timer variable, like a starting time, and then you can set it equal to millis with parentheses. You have this value that's stored in a variable that represents the start of that timer, when it started. And once again, just a reminder, the function millis returns a value that is equal to how much time has passed since the program started. Now, timer end, this can be a couple of things. So we can have this one case where we stop a timer based on an event. Button is pressed. Maybe if we have a noise sensor, maybe if when someone screams bloody murder, then we stop the timer. The second case can be that this output is stopped based on when we reach a certain time. Let's say like we press a button, the timer starts, LED starts blinking. When the timer hits 5 seconds, then the LEDs stop blinking. So there's a lot that we can do with timers, right? And it's not just these two things. We can start getting way more creative with it, but let's just focus on these for now. When we're trying to listen to an event, we can use conditional statements, like if-else statements. If some button is pressed, then you can see how much time has passed by subtracting the start time, right, our timer start variable, from the current time. For example, we press a button to start the timer. Then we can have a conditional statement saying if that second button was pressed, then we want to calculate the amount of time that's passed. So we take the current time, which we can figure by calling the millis function, and we want to subtract the start time from that. And then we can get the duration of how long that our timer has been on. We always want to use unsigned long as our type for timers. This type stores values from 0 to like 4,294,967,295. Wow, that's a lot. Let's get into a super important part of this class and beyond in your coding life, pseudocode. So the most important part of programming, and it should account for most of your time, is pseudocode. What is pseudocode? That's a great question. That's a really good question. Pseudocode is a way of expressing an algorithm without having to abide by those pesky syntax rules. It lets you think through the problem with written words or spoken words instead of overwhelming your brain with how do I solve this problem logically, and then also where does that semicolon go, and how do I close this curly brace, and what the should I name my variable? Worry about all of that syntax later, as long as you start to think like a programmer and solving problems step by step with the tools that we have, like variables, conditional statements, relational operators, blah, 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 blah. Let's do an example. We're going to turn on an LED after 5 seconds of our program running. Super simple. All we want to do is start that program, and after 5 seconds, we want to turn on the LED. So we're gonna have to think through, you know, what we just talked about in this lecture before we jump into the IDE and actually code this. So let's think about it. Seems pretty easy, right? But we're thinking too big picture. We gotta start digging down into step by step how we're going to solve this. So the first thing we might have to do is declare and initialize this duration variable to a certain amount of seconds. So we know in our head it needs to be an unsigned long type. We know we want to name the variable with something that makes sense, maybe like duration. And we want to set it equal to a number that represents the unsigned long, so milliseconds version of our time. So 5,000 instead of 5. So we want to do that before we even jump into our setup code, right? There's a reason why we do this. If you want to use that variable in another part of your program, it has to be what's called in scope, which means that if you're in a function like loop or setup and you want to use that variable, it's got to know about it. And how we make sure that the program knows about it is we're going to just throw it on top of those functions. And we're not going to worry too much more about scope because that's a little complicated, but we're just going to put that there knowing that in our loop and in our setup functions, we are able to call on those variables, and those variables will bring you the value that you stored in them. And they will also allow us to change the value that's stored in them. Pretty cool. So first, before setup, declare and initialize a duration variable to 5,000. All right, that's what we're going to do first, before our setup, before our loop. Then in setup, we want to configure the LED pin to be output, right? We got to like do a handshake with that LED pin and be like, are you chill with being output? And it's going to be like, yeah, because usually always it says, yeah, this is pretty cool. This is fine with me as long as it's the right pin. So once we configure the LED pin to be output, then we can move on, still in setup, and we want to think about how do we want to start this program? Do we want to start it with the LED on or off? It automatically starts off, but just to be sure, we could insert a line of code that says turn LED off, right? Make sure it starts off. Makes sense in our head, right? Setup, want to make sure it starts off. Now we can do the fun part. Now we can jump into like our logic, right? Which is going to happen in the loop function in our Arduino sketch. We want to make an if-else statement that says, well, if the current time that the program has been running is greater than the specified duration, so we would figure this by calling our millis function, which gives us the current amount of time that our program has been running. If it's less than duration, which is the variable that we assign to 5 seconds, then we want to turn on the LED. The reason why we do this pseudocode and we write it out in our language that we're familiar with first, and it's easy to translate that into code rather than trying to skip a step. It's going to save you a whole lot of time. It might not feel like it because you're like, I'm doing 2 things instead of 1, but trust me, please trust me, always write out in pseudocode before you jump into the IDE and solve the problem. Here's our Arduino. It's on, green light, we're good to go. So let's go back into our Arduino IDE. Remember our sketch here. We've already made sure that we have initialized our serial communication rate to 9600 by using serial.begin 9600. And then we're going to look at our pseudocode, IDE and the other. We've literally already written this program, we just gotta kind of translate it into code. So the first thing we want to do before setup is declare and initialize a duration variable, and we want to set that equal to 5 seconds or 5,000. So unsigned long. We're going to call this duration. We're going to set it equal to 5,000. Just as easy as that. You can check it off your list. Okay, in setup, we've already been like, hey, serial monitor, is it cool if we talk to you? So that's fine. We've set that up. Now, we want to configure the LED pin to be output. So the only kind of LED that we have at this point in the course is the LED that's on pin 13 on our Arduino. So there's a couple ways we can do this, right? We can say pin mode, and we'll go, I'll have another slide on reminding you how to do this when you do your code challenges, but we can type in pin mode, and we're going to send in the number of the pin and whether it's going to be output or input. So output, right? There's the second way we can do it, and I think it's a lot prettier and it makes a lot more sense. We can say int, and then we can say like LED pin, and then we can set it equal to 13. And there's our variable. So we can just type in LED pin. And it's way more readable when you do this, and it's highly recommended. After we configure our LED pin to be output, now we can kind of initialize it to be turned off when our program starts. It'll automatically do this, but just to be safe, we can go ahead and do that real quick. It's also good learning stuff. So we want to digitally write, so digital write, and then we want that LED pin to be turned off, and that's going to be low, if you remember from Jesse's lecture. Okay, so we've done that. We can check number 2 and number 3 off our list. We are just like piling through this code right now. So plowing through this code? Sounds good. In loop, now we want to make a conditional statement. This is how you make a conditional statement in C++. This is the language we'll be using to kind of communicate with our Arduino this semester. So we're going to type if, parenthesis, and it fills it out for you. It completes your parentheses. Now you have an opening and closing and bread to your sandwich. And then we're going to put a relational operator in here. Relational operators, if you remember, are like equal to, greater than, less than, greater than or equal to, greater than or less than. So what we want to do is see if there's a certain amount of time that's passed. And we can do that by saying if the current time, which we get by calling the millis function, is greater than, so if the time that the program has been running is greater than the duration that we set, we can find that by just calling onto the variable. I want to show you something cool real quick. Let's say we declared and initialized this variable in setup. This, in loop, it doesn't know what it is. It's like, I don't know what the duration is. Like you talked about that in a whole different conversation with somebody else. I have no idea. That's why we want to declare and initialize our variables outside these functions to make sure that everybody is able to call on them, no matter where you are in the code, in setup or loop. Back to the if-else statement. If the time that the program has been running is greater than the duration that we set, then we're going to do this curly bracket. Does the same thing with the parentheses. It closes it automatically. You hit enter, and now we can put in that meat, right? So if that certain amount of time that we specified has passed, then we want to turn that LED on. So just like we digital wrote the LED pin to be off in the setup, we're going to do digital write LED pin high. But let's make this a little more fun. Let's add an else. So if we add an else, we do these curly brackets, we hit enter, then whatever I'm typing here only gets listened to or only executes if this is false. And that means if the certain amount of time that's passed isn't greater than the duration or less than or equal to the duration, then we're going to do whatever is in here. So let's write to the serial monitor. We're going to do serial.write. We're going to put not yet. All right, let's test this out. So first we're going to verify our code. Seems like it compiles just fine. Now let's go ahead and upload it. So let's test it out on our hardware and see if our code's working the way that we intended. I'm going to hit this reset button. And what we expect once we reset it is for the LED down here to not turn on for 5 seconds, and then after 5 seconds it turns on. So let's see. Let's hit the reset button. 1, 2, 3, 4, 5, and then it'll turn on. So now we're going to jump into our coding challenges. Remember that the slides are going to be on Canvas, and the very last slide is just a few kind of reminders on how to turn our LED on and off and how to initialize and declare variables and all that good stuff. So make sure to use your resources and good luck. So for your homework, you are going to complete a few of these coding challenges that will all lead up to you writing a full program for a stopwatch so we can time ourselves to see how long it takes for someone to list their favorite 5 TV shows. So you'll see that there's 4. We have coding challenge 1, which is declaring and initializing your variables. Coding challenge 2, wow, I cannot talk this morning. Coding challenge 2, which is all of the code that we're going to be putting in setup. Coding challenge 3, which will be a function. This is going to be a big one, writing functions. So this function isn't going to return anything, but it's going to listen to see if a key is being pressed. So you'll be finishing that function, determining whether we're going to start or stop our timer. And then the final coding challenge is much easier. It's just configuring the LED to turn on or off, depending on whether we're using our timer or not, or our stopwatch or not. So you can find this set of coding challenges in files on Canvas. Our slides from this lecture will be on files in Canvas as well, so you can kind of have those open while you're working on this. It'll be pretty helpful. We're going to have this due Tuesday before class, so Tuesday at 2 p.m. I think that's all I got for you. Be safe. Don't drive right now. It's really dangerous out there. And we'll see you on Tuesday. Okay, bye.